participants, thanks a lot for being here. And Stuart, especially thanks to you for putting out your time to make this happen. And, this is really, we're trying to put these things on more and more to serve the entire industry. And grateful for the likes of Stuart for really dedicating his time to bring remote training to our industry when it's during a time when it's hard to do in-person training. Shane, I don't know if you have anything to say before we launch, but I'll hand it off to you.
Thank you. All right, guys. Thank you so much. It's really good to see you guys. I think we've got a relatively small crew, but a mighty one. And we're going to spend about 3.5 hours, or until you can't take it anymore, doing what's required training on cylinder inspection requalification as it applies to PHMSA requirements for those that are doing visual inspections, visual external inspections. And really what we're going to spend a lot of time in is actually picking up and using the PERC book, the PERC textbook, which I assume you all have. And if you haven't opened it up, please open it up and go through the table of contents just to give yourself a little familiarity with it. Now, I know how it is. Sometimes we purchase training materials and they're not always used. And so we want to make sure that you're able to use this book as a tool, which is what it is, to be able to determine various criteria as it applies to requalifying cylinders. If you go to the back of the book, you'll see a big fold-out chart, a DOT cylinder requalification by visual inspection chart. We're going to refer to that a lot because there are a lot of criteria in which to look at when you're inspecting or requalifying a cylinder, but within those criteria, there are also sub-criterias like corrosion. Well, how much is too much corrosion? Denting. How much is too much denting? Right? And so that's what we're going to talk about. We're going to go back and forth a lot. We're going to go through the tables to make sure you know how to use this book as a resource. We're going to take some quizzes throughout the 3 hours. We're going to take a final quiz. And I'd like to save all questions until the end. And maybe we'll take a few-minute break. So without further ado, and with this course also, you will get a certificate of completion, which will be important for you should you require a RIN number from PHMSA. And we'll talk about what you need to do that. But even if you're not requalifying, even if you're just doing the inspection, you don't need a RIN number. This is really a great course for you. We remember, we'll get this going in a second. There we go. Remember the Philadelphia food truck explosion? We've got to start off every safety.
In Philadelphia, mother and daughter are in critical condition this morning. They're among 16 people injured when a food truck exploded. A propane tank blew up last night outside an auto body shop, causing a huge fireball. Oh, wow. And mother and daughter were working inside the truck. 2 cars driving by briefly caught fire.
Now, there's a lot of finger pointing in this one, but the fact of the matter is, what had happened was, if you don't know, somebody filled a vertical 100-pound cylinder that should not have ever been filled. It was about 60 years old. It was damaged, but somehow somebody filled it. And the company that was accused of doing that settled for over $160 million in fines, and a manager at the local store where it was alleged filled almost went to jail. I actually had, at that time, the assistant district attorney from Philadelphia in my office talking to me about this. So I'm sure no one would fill that cylinder, but the issue is that we're going to talk about paperwork and documenting those things. Because a lot of times, or what could happen, somebody takes a cylinder home, sometimes there's an incident or an accident, and they'll say, well, the guy that filled my cylinder didn't inspect it properly, et cetera, et cetera. You have the proper paperwork, you're going to be in pretty good shape. While it may be a little bit mundane, you are professionals, and you are the last line of defense between an accident and the safety of your customers. And sometimes you just may not feel like doing that inspection the way you should. But it's critical that you do. You know, I always say, you know, if I go to the doctor, if I have a disease, if I have a brain issue, I want him to be on his game all the time, every time, whether you got to pull out a checklist or not. That's the same thing with you, gentlemen. People count on you to keep them warm, keep them safe. It's really important. I know it may sound a little sanctimonious, but it's not. So let's start with a couple of video clips. Some of this will be pretty simple to you. We're going to start slow, and then we're going to really kind of dig in. So just a quick introduction to various types of cylinders.
Cylinder requalification. Propane cylinders provide a portable and convenient way for residential, recreational, and commercial users of propane to fuel equipment and appliances. Propane cylinders can be found at many locations, including hardware stores, professional landscape companies, campgrounds, rental equipment companies, and gas stations. In order to ensure your safety and the safety of your customers, propane cylinders must be inspected prior to each time they are filled. One step in the pre-fill inspection identifies cylinders that are due for requalification before they can be returned to service. The purpose of this video is to be a supplement to the cylinder requalification textbook. Please make sure you thoroughly understand all of the principles, instructions, and guidelines that are in the textbook. The textbook also serves as a reference guide, as it contains many of the charts, tables, and measurements required to requalify a DOT cylinder.
Okay, pretty straightforward stuff. These are the organizations that you'll probably deal with in terms of cylinder requalification, NFPA, OSHA, in terms of workplace training, DOT, transportation, EPA, don't spill anything, and the Compressed Gas Institute, of which this document really takes its information from. Now, let me start off with some really good news. You might know that NPGA was very successful in convincing PHMSA, and this is something that's been going on for a long time, that it used to be you had to have a copy of CGA 6 at the facility in which you are doing a recertification of cylinders or inspections by external visual. And those books cost about $200. And if you look in here, that's not required anymore from PHMSA. There's a link that gives the formal interpretation of that, or the formal directive. And that as long as you have the PERC book, this one here, you do not need to have the CGA 6. Now, what I would recommend is that in every place that you do that recertification, that you have the PERC book, and also download the link that talks about the PHMSA link, which you'll see on the bottom of this handout. Bill, I believe I sent some out. I can happy to send some more, and it's on NPGA's website. And this is kind of a big deal, especially for companies that have a lot of facilities. And plus, it just never made sense to have to keep the book. So it codifies that using this course is good for training, and having this booklet in lieu of spending $200 for CGA 6 at the facility. It was just pretty good stuff. I suspect the folks at CGA were not happy about that, but let's face it, we don't really care. Okay, what are the objectives of this course? Of course, you know, in every class, you have to at least go very quickly over the properties and characteristics of propane. Even though I suspect most of you folks know that, we're going to do that quickly. Identify the different types of DOT cylinders. Identify DOT requirements for cylinder requalification. List the processes for steps of visual requalification as it applies to visual inspection, and the documentation of these things. And that, you know, we're safety and we're professional. We do things because we're professional. And as I said, people count on us. So when we talk about pre-fill inspections, right quick, these are the things that we're going to look at. Now, I've got notes pages up. You may be able to see those notes. If you can, that's all right. So you can hear me, you can see the screen, and you can see some of the notes that I'll be using. But not too long ago, a new requirement in NFPA was to remove the plastic or paper sleeve that often comes on the cylinder. Why? Because it's been shown that there could be a lot of rust spots, especially by the weld, that can weaken the integrity of the cylinder. So you have to do that. You have to remove those things. Look for cracks, leaks, serious dents. What's a serious dent? We're going to get to that. That's where we're going to go to the table and figure those things out. Defective valves, defective face seals. Defective face seals that you have to inspect is also a new criteria in NFPA. Defective leaking pressure relief valve, damage to cylinder foot rings, collars. Fire damage. How much fire damage is too much? Excessive rust or corrosion. What is excessive rust? We're going to talk about some of those things. And out-of-date requalification. All righty? So, very quickly, I'm just going to show this video on properties and characteristics of propane because there could be
properties and characteristics of propane. The safe dispensing of propane involves knowing its properties and characteristics and being aware of safety procedures. A safety data sheet, or SDS, is available from propane suppliers or distributors and must be available and accessible to all employees at the workplace. The SDS provides important information on propane, including physical properties, health effects, first aid, safety precautions, and personal protective equipment. Propane is stored as both a liquid and a vapor. As propane liquid turns to vapor, it expands 270 times. Because of the large expansion rate, a liquid propane leak can be more hazardous than a propane vapor leak. Propane containers are usually filled to only 80% of their capacity to allow room for liquid propane to expand with an increase in temperature. Propane is non-toxic, but its vapor can be dangerous to inhale because it can displace oxygen. Since propane vapor is heavier than air, propane released in a confined space may settle in low-lying areas. However, if there is sufficient air movement, especially outdoors, the vapor will quickly dissipate in the air. Propane liquid becomes very cold when released to the atmosphere. This means if it comes in contact with your skin, it can cause frostbite or freeze burns. For this reason, appropriate gloves or other personal protective equipment resistant to propane should always be worn when filling containers. Your employer may require other safety equipment depending on your specific responsibilities, so be sure to check with your supervisor. Propane is a fuel. It will ignite and burn under the right conditions. 3 ingredients are needed to start and sustain combustion: propane, oxygen, and an ignition source. In order to minimize possible ignition sources that could lead to combustion, customers should be restricted from the immediate area around the liquid propane transfer areas. A strong, unpleasant-smelling chemical is added to propane so you can detect it. The chemical added to propane makes it smell like rotten eggs, a skunk spray, or a dead animal. You should respond immediately to even a faint odor of propane. If for any reason you cannot recognize the smell of propane, notify your supervisor immediately. Both you and your customer's safety could depend on your ability to smell propane in the event of a leak. You should be aware of any potential ignition sources anytime you are handling or transferring propane. Some examples include a person smoking, open flames, internal combustion engines, and static electricity. Make sure you eliminate any potential ignition sources before handling or filling propane cylinders and tanks. In the right conditions, a source of ignition, such as a static discharge or spark, may cause the ignition of some fuels, including gasoline and propane. For more information on controlling static electricity,
Okay, you all got that? All right, let's get right into it now. DOT cylinders, we're starting on page 5. I know you guys know a lot about this, but let's go over it anyway because we've got to do it for the class. Important part of the cylinder requalification's job is to recognize the various types of cylinders, their markings, and we need to make sure that when we do that, that we could tell whether or not the cylinder is still within date of its last re-qualification. We want to look at things, as you can see on the bottom here, like these rings under here that keep the integrity. If those are damaged, that's a no-no. All right, common elements of DOT cylinders. Valves. Exchange cylinders have one combination service valve, pressure relief valve screwed into the top. Vertical cylinders with 4 to 40 pound have to have OPD valves, right? We all know that. We want to make sure we know that. Protective cylinder valves, a wide metal band. It's the collar welded to the cylinder body. Collars are where we have a lot of that information on. You'll see, and we'll go over that in just a moment. You can see it's a DOT number right up here. It'll have other information on it. And as we know, we lift by the collar. Okay? ID markings. All the ID markings that you're going to look for are on the collar. Markings are required by DOT. The ID card for the cylinder, right? It has all that stuff. It has the cylinder specification design code, service pressure, pair weight, right? Water capacity in pounds, test a requalification date. That's where you find all those things. Okay, let's go to pages 8 and 9 in your book. We're going to do a quick discovery activity. I'm a big believer in making sure that folks are doing stuff. Okay, you with me? You see on portable cylinder markings, you'll see in 8 where the cylinder up in the top left corner, cylinder tear weight. Cylinder tear weight is 17 pounds. You look on the collar, where's A? Tear weight, 17 pounds. B, water capacity in pounds. Where do we see that? B, water capacity, WC. C, manufacturer's name. We're going over to the other side of that collar. This one's owned by General Cylinder. Specification design code. The specification design code on letter D, on the third picture that you see here, has the DOT 4B8240, manufacturer date. On E, on F, requalification dates. These are incredibly important. You're going to figure out whether or not the cylinder is within requalification date where it can be refilled. And let's take a look at that right now. Requalification markings. Now, you may recall that a few years ago, PHMSA had put out a rule saying that the volumetric expansion test went from 12 years to 10 years, and that the internal hydrostatic test went from 10 years to 7 years. They have now, PHMSA put out a correction on that, going back to the original 12 and 10-year dates. The reason that we have it this way in the book is because that was not adjudicated yet. And now we know that the original dates are what those dates are. So when reading the original date requalification markings, a date without a letter, right? No letter, no stamp, just a date. Next requalification must be within 12 years, not 10, 12 years, right? They first changed it to 10, then back to 12 again. The letter S following the date indicates a cylinder must be requalified within 10 years of the marked date. S, internal hydrostatic. And E, which is one that you're going to see probably most often, indicates requalification date within 5 years. And cylinders may not be requalified. They may not be refilled if they are past that requalification date. Okay? Let's go back to the learning activity on page 9. It's the other picture. You see a vertical cylinder, right? First we saw a small 40 pounder. Now we're going to see a 100-pound cylinder or exchange cylinders. It's the same thing. If you look where, from the top view, you'll see where the tear weight is. You'll see where the water capacity in pounds is. You'll see the manufacturer's name, et cetera, et cetera. That's where it's located on a 100-pound vertical cylinder. And again, on letter G, we see an E at the end, 1005E. That means it has to be requalified within 5 years, right? 1005E, okay? So that's how we want to look at these various cylinders and where those markings are at. This is why I say that this book is a really, really neat piece of reference material. Potential cylinder problems, right? There's tons of them, right, guys? You know this better than I do. Steel cylinders could be subject to fire. Aluminum cylinders subject to fire. If an aluminum cylinder is subjected to fire, it must be permanently removed from service. A steel cylinder can be repaired and put back in service if it's believed that it's financially worth doing that. If it's an aluminum cylinder, it gets fire damage, it's done. Why? A little bit of an obvious reason. The integrity of a steel cylinder is much greater than that of an aluminum cylinder. If you encounter a cylinder with 3 X's over DOT specification number or marked condemned on the shoulder, collar, or head, can't be requalified. It has to be set aside in a safe area. Okay? And we look at cylinder labeling. Pretty familiar with all of this. Cylinders used to transport propane must be clearly and durably marked with the proper shipping name. Cylinders used in industrial applications have various other warnings. So you have the NFPA, flammable. You probably have some other information here. This is where the manufacturer puts their information on. And a consumer information label, which is what this person is putting on now, or warning must be on all portable refillable cylinders of 100-pound capacity or less. All right, DOT requirements. We're going to kind of get into it right now. And I know if I'm being repetitive, it's because I want to really make sure you really understand this information. The process by which a DOT container must be taken out of service, retested, and found suitable for continued service on or before the required date. That's what we're talking about. Most of what we're going to look at, most of what you folks are going to do is really look. Right? You're not going to be doing the requalification, and you probably may not be doing the putting a number on the collars. Talk a little bit about the different types, the dates of when a cylinder needs to be requalified, and there'll be various other numbers on the cylinder. We have cylinders 4B, 4B8, 4BW, 4E. Those will be requalified within 12 years. After that, volumetric testing. There are others if every 5 years after, if we qualified by external vision, indicate the date following. Pretty straightforward. Okay, you'll know what type of cylinder it is, right? You'll know what type of cylinder it is, whether it's 4B, 4BA, 4BW, where you'll find it on the collar, as we just went through a little while ago in the learning activity. You have to be trained. That's why we're here. We're going to go through this training course. I know some classes will do this in, 5 hours or so. My sense is 3.5 is enough information that I believe you'll be fine with this. And I know that a lot of you will go back after this class or where you are, and you'll have somebody do some hands-on training, which is also vitally important for your RIN number. Now, it doesn't have to be anything formal. What we're going through, so have somebody say, okay, show me where those RIN numbers are. Show me that you know what you did in this class. You'll then you'll send the application to PHMSA, and you will be good to go. And remember, you need refresher training every 3 years. As it applies to NFPA, you will need to be recertified by PHMSA every 5 years. So here's a requalification application on page 16 of your booklet. This is an example of one, and you would fill this out. You'd put down if you have a RIN number or if it's a new application, you would include the certificate of completion that you received from this course, and perhaps a note of the visual guidelines and the hands-on testing that you have received. It's pretty straightforward, but this is the first step of getting you there. Okay, let's go through a quick video. We're going to do that. We're going to intersperse with some slides, some videos, some quizzes, some learning activities. Okay, so let's go to this video and talk a little bit about DOT requalification requirements.
DOT requalification requirements. DOT regulations require the retention of cylinder requalification reports and records. Reports and records must be maintained at each facility where cylinders are requalified, repaired, rebuilt, or condemned. Required facility records include current copies of DOT regulations applicable to cylinder requalification done at the facility. Information provided in the Compressed Gas Association or American Science for Testing and Materials Standards in accordance with pamphlets, if applicable to cylinder requalification done at the facility. A current requalification number, or RIN, issuance letter where applicable. Facilities must reapply for the RIN every 5 years. Requalification record pages for external visual inspections must document the following: date of requalification, cylinder serial number, DOT specification or special permit number, marked pressure, which is included in the DOT specification number, actual dimensions of the cylinder, manufacturer's name or symbol, owner's name or symbol if present, result of the visual inspection, cylinder disposition with reason for any repeated test, rejection, or condemnation, legible identification of the test operator. The option to use a single date for each record page is acceptable if each requalification inspection on that page is done on that date. The use of ditto marks or a solid vertical line to indicate repetition of the preceding entry is acceptable for the following entries only: date, actual dimensions, manufacturer's name or symbol if present, owner's name or symbol if present, test operator or inspector. Blank spaces may not be used to indicate duplicate results of repeated operations. The cylinder disposition is the final determination of the cylinder inspector as to its status. After requalification inspection, every cylinder is assigned one of the following dispositions. OK. The cylinder has passed the inspection and is requalified for another 5-year period. R or RM. Rejected or removed from service. The cylinder must be repaired or rebuilt and inspected again before it can be requalified. SC. Scrapped or condemned. The cylinder must be permanently removed from service by marking the cylinder or rendering it incapable of holding pressure. Requalification records must be maintained at the facility until either the expiration date of the requalification period or the cylinder is requalified again.
All right, so I think that makes a lot of sense in terms of the things you could use ditto marks on because you're going to be the same person. And so I think that's fine. Now, remember that it said, and I'm going to show on this slide, that you need to have, it said this CGA book at the facility. But we said a little bit earlier, and I shared with you the note, the fact sheet from NPGA, hats off to them, who approached PHMSA and said, look, we've got this great PERC book. We did it. It's based on CGA. And we think that should be acceptable to have at the facility where requalification is occurring. We don't need to spend $200. And darn it, PHMSA agreed. And I suspect that at some point, this will be addressed in a new version of the material, but that is very good news indeed. Okay, if you look at page 18, or should I say 19, I'm sorry, in your book, you'll have an example of records and reports. You could use something like this, or you can use your own. Again, the date of requalification, cylinder serial number, DOT specification or special permit number. Special permit maybe for cylinders such as composite cylinders. Marked pressure, actual dimensions of the cylinder, manufacturer's name or symbol, owner's name or symbol, cylinder disposition with reason for repeated test rejection or contamination, legible identification of the test. There's a lot that you have to fill in here. And again, it's critical to have that documentation. If an accident happens, and you haven't had the documentation, say for whatever reason, the cylinder has to be condemned. What do? Do you tell the owner you can't use it? It's their property, right? This is if somebody comes to a facility for a refill, not if somebody's looking at cylinders set aside. And that person goes ahead and they go ahead and refill that cylinder someplace else. I guarantee it happens all the time. When something happens, somebody says, well, I went to Stu's Propane, which would be a crazy thing to do to begin with. But I went to Stu's Propane and he didn't do anything. You have the documentation to show. So again, it's either going to be marked okay, which means it's okay for requalification. It's okay to go. You're going to have it R or remove. And R or remove, that's going to be up to, your policies as to whether or not it is financially viable to actually recondition a cylinder that has been removed. Sometimes, it can be pretty pricey to recondition a certain cylinder. We'll talk about that. And some folks choose to just go ahead and condemn them. Well, you'll mark it SC, meaning that it's scrapped or condemned. So it's going to be okay, R or RM, or SC. That's how the ultimate disposition of those cylinders are going to be. Keep records. I'm really big on record keeping. If you haven't documented it, it's not there. Requalification records must be maintained at the facility until either the expiration of the requalification date or the cylinder is requalified again. Okay? It's pretty straightforward. It's time for our first check for understanding. Let's go to page 21, and we're just going to go through these together. Your boss has asked you to help him or her set up the cylinder requalification process at a new facility. From the list below, identify the DOT requirements from which you based your recommendations. Okay, your boss says, hey, we need a cylinder requalification process. What are the things that we kind of need? Well, we definitely need the DOT requalification schedule. We really don't need the NFPA codes and standards. We're going to get trained through this book. And plus, it's not necessary for what you're doing. You're going to need C, requalification reports and record retention specifications. You don't care about American National Standard Institute requirements. I think you're going to need external visual inspection personnel qualifications who are qualified. And for this purpose, you have PPE, you have all these things, you're good to go. But it's A, C, and E is what is really required to set up a requalification process at a new facility. Okay? And again, I want to go through this and we'll have discussion at the end or during a break. The reason I want to just go through this is I think it's fairly straightforward. And I really want to make sure that I don't keep you folks longer than you have to be kept. Okay, so I appreciate your indulgence. Okay, we're moving on now. We're starting on page 23, the requalification process. First, just an overview. Your man or woman is going to pick up the cylinder, is going to take a look at it, do a quick visual inspection. Now, friends, you probably know better than I do. In my opinion, the biggest challenge in dispensing facilities is the high turnover of people that do the operation. A lot of propane marketers that I know will go ahead, they'll provide the training to the dispenser operator, and that dispenser operator is on the hook for making sure their people are trained, and they're on the hook for ensuring that when there are new people on board, that propane marketer is contacted for retraining and even hands-on. But it is a real challenge. There's a lot of turnover. I have gotten my cylinders. I have sent barbecue cylinders for refill, and the visual inspection of those has been very cursory, to say the least. Okay, we're going to now get into the chart. We're going to start getting into the steps, the decision tree of what is required in the requalification process. Those 4 parameters are basically being prepared. You're going to verify the requalification date. You're going to gather the forms that you need. You're going to inspect the cylinder for fire exposure, distortions, neck or valve damage, attachment damage, dents, cuts, gouges, dings, corrosion. You're going to leak check the cylinder if it has all of those things, and then you're going to determine whether or not it's okay, or whether or not we reject it, or whether or not we'll scrap it. And for most of the rest of this course, we're going to go back and forth with this chart and use the various tables and processes to make that determination of how much damage, how much corrosion, how many cuts, gouges, or dings are too much. Okay, so first we're going to prepare the cylinder. Okay, you're going to verify the cylinder date requirements, as we spoke earlier. If it's in E, it's for visual inspection, has to be inspected within, had to have been requalified or inspected within 5 years of which it's stated. Probably a really good idea to kind of clean off the cylinder a little bit, because we know a lot of dirt and rust maybe can hide some imperfections or some gouges and digs or some other defects that are really, really important to be able to take a look at. Okay, we're going to gather all the forms that we need, right? We talked about the cylinder inspection forms as we looked at on page 19. That's an example of a form. We're going to have all of these things with us. Okay, we're going to be ready. Okay, so got our cylinder. We cleaned it up a little bit. We've looked at the date numbers. Those all jive. Those look good. We're starting to fill things out. And now we're going to do the inspection. We're going to inspect this entire cylinder thoroughly for signs of exposure, any type of damage to valves, appurtenances, any part of that cylinder. We're going to look for signs of corrosion or distortions. If it reveals any corrosion, cylinder should be emptied and weighed. Any corrosion, emptied or weighed. And again, we're going to get into some more of those specifics. We're going to leak test the cylinder. I served as a subject matter expert on a lawsuit where somebody did something they shouldn't have done to the cylinder. And the fellow that filled the cylinder swore up and down, even he's deposed, he's under oath, that he leak checked all of that, right? He did all that. But what didn't he do? He didn't write it down. He didn't write it down. And you know what? I hate paperwork. I really do. It can be the most tedious thing in the world, but it is just critical. And I can't emphasize that enough. Whether it's doing a gas check or leak check or doing this, the documentation is critical. And that is part also of being professional. In the process, when you look at the cylinder, you're going to mark it again. It's okay, it's rejected, or it's scrapped. Okay, cylinder disposition, that's going to be documented. And it's just a high-end overview. Okay, cylinders that do not pass inspection are given a disposition of rejected, removed, or scrapped, marked appropriately, and if necessary, completely removed from service. Fill out the inspection report completely. Again, just a big overview here. Let's go to page 29 in your book for another quick check for understanding. Match the cylinder requalification task with the appropriate part of the cylinder requalification process. Some answers are used more than once. So one, we're going to prepare. What part of the process do we do for preparing? Determine the cylinder requalification date, right? That's part of the preparation, as well as obtain the cylinder inspection report. That's also part of the prepare. B, we're going to inspect, check the cylinder for fire damage, right? On these criteria, that's what we're going to inspect. C, leak check, charge the cylinder with propane vapor. Under process, what things we need to do. Document and return the requalified cylinder to service. Or we may need to condemn it, scrap it, set it aside, or mark it as repair. So we've got prepare, inspect, leak test, process. Those are the 4 basic criteria. And I'm just going to hammer them to you until you just can't take it anymore. Prepare for requalification. You go to page 31, you can see within that long chart that you have just this one part. Okay? This lesson is going to look at detailed process for preparing the cylinder requalification, not just the overview. All right? Review the entire decision chart again. At the back of your book is a big fold-out decision chart. So what we're doing now is that we're just taking pieces of that decision chart, breaking them down into small tasks to make it more manageable and easier for you to understand. We're going to look at a quick video, and then we're going to go back to the book.
Prepare for requalification. The first step is to make sure the cylinder is not leaking. If it is leaking, immediately take it out of service. Next, determine whether or not the cylinder is due for requalification based on the manufacturer requalification date. If the cylinder is not due for requalification, then a simple pre-fill inspection is to be performed on the cylinder to determine its suitability for continued service. If the cylinder is due for requalification, then the cylinder must pass the entire requalification inspection in order to be returned to service.
It is really not rocket science doing this. It's a matter, again, it's just rote, doing it. It's like anything else. It's a matter of doing it the right way. And it's so easy. It's so easy for us. Obviously, Bill, you're kidding. And I love a good joke. But it's so easy for us to take the path of least resistance on some of those things, but it's that one time where you're like, it looks okay. I got to leave. I'm going to my daughter's birthday party. Whatever it might be, we all get kind of disorientated sometimes, or it's freezing cold outside. My suggestion, and I'm not the boss, is, take a break, take a deep breath every once in a while. But this is really, really critical work. It's like anything else. 1,000th time somebody does, someone's done a shortcut 1,000 times, and it's 1,001th time, and it could be that many times that they get into a jackpot. And so, like I say, I don't want my doctor to take shortcuts. And even if my doctor's got to review a chart, as a matter of fact, just as an aside, there's been a trend in surgical facilities where there are checklists for doctors. Not what to do if you find a tumor, but just various protocols to make sure that they're doing it the same way, the same time. And I actually think that's a good thing. So if you have to go back to this book, if you forget it, that's fine. Go ahead and do that. That's what professionals do, and that's what everyone on this call is. Okay, enough of my soapbox talk. I'm very big on that. Let's look at page 32. Okay, prepare for inspection. So we'll take a look at all of these, items, okay, based on manufacturer requalification date. Is the cylinder due for inspection? Okay, perform a simple refill inspection, perform requalification inspection. So let's see. We are looking at, let's say it's type 3A, it's 5-year inspection date, not available, 4B. All of these look like they're pretty good. If they come up, if the numbers look like this on the chart, then yes, you can perform the requalification, continue to perform the requalification inspection. And let's get a little bit more specific here. Requalification periods for DOT inspection. Look at the head of the collar. Read the DOT specification number, right? That'll tell you the type of cylinder that it is. Determine the type of test. No letter, water jacket, E, external visual. We're taking a look here. It's a 4BW. It's going to be 12 years, external 12 years, 5 years. Let's look up here. Okay. This had the external test. The last time it was tested was October 15th. As of today, October 15th, can it be requalified? No, it's a month out, right? It's a month out. It's gone. The next requalification should have been October 20th. You see what the cylinder type is from here, 4BW. We see it's got an external visual inspection. Why do we know that? It's got the E there, 5 years.
I actually do have a question here. So it sounded like from what you just said that if the cylinder has expired, and say it expired and a year or so has passed, we can't requalify it then for future filling?
It will have to be requalified with a new date on it.
Okay, sure.
Yeah,
but
you don't have to scrap it. You just can't fill it.
Right, okay, that's the way we've done it. I just misunderstood that.
You are
okay,
correct.
good.
Well, that's a great question because that really does clarify. We start throwing words around. You just can't refill it. So again, how important is it the documentation? Somebody comes to your facility and you're like, man, you should have been here last month. And the guy's like, dude, I got $50 steaks waiting. My wife's going to kill me. You're really tempted to say, hey, okay. You really are tempted. You feel sorry for the person or whatever. That's not being professional. And you say, I can't do it. You can't you got to give him back a cylinder. It's a good chance you're going to go somewhere else and it's going to get filled. But you've documented it and maybe made whatever note that you've made. And you've retained that. In this case, you may want to retain that forever. It's not your cylinder. If it's one that's your cylinder alone, then of course you'll have more control over that. But you're right. You don't have to condemn it. You don't have to repair it right then, but you cannot be refilled. Okay, let's go on page 35. Check for understanding. The following requalification dates are found on cylinders at your facility. All cylinders are 4B, 4BA, 4BW, or 4E. Using the chart below, check when the next requalification is required. So 1014, no letter. So what does 1014 mean? Water expansion volumetric test. Has to be within 12 years. This one was done October 14th. Is that within 12 years? Yes, it is. Okay, we're following the chart. We're seeing that it was requalified via the volumetric expansion test. Why do we know that? Because there is no letter next to the requalification date found on the cylinder, because it's marked 1014, no letter. Here's the next one, 0716E, E, external, 5 years. Well, this is good for another, almost for another year, right? 16 plus 5, 21. And 512S, S means that it was recertified or certified using, or requalified, I'm sorry, using the internal hydrostatic test. How do we know that? Because it says S on it. And those that are requalified within the, using the internal hydrostatic test are good for 10 years. For those that might have missed it, PHMSA went back to its original requalification dates of 5 years, 10 years, and 12 years. The reason you might see a 7 or 10 or 10 or 12 is because the booklet had not been updated in time, or should I say PHMSA more than likely just recently came out with that clarification. So again, we're looking, is there a letter after the date? No, there's no letter after the date. That tells us it's volumetric expansion test. That means it's going to be a 12-year requalification. We see 716E. The E tells us it's external visual, which is what most of the time you'll be doing. So that was first requalified in 2016, 7/2016, 5 years, still under requal, still good to go. And the last one, 5/2012 with an S, the S meaning that it's internal hydrostatic test that is good for 10 years. It'll expire May 2022. So we're still good to go from here. And that's why we want to kind of go through some of these. And again, questions, I mean, throw them out as we're going there. We're going to move on to visual inspection report form. We're going to show a quick video, then we're going to go back to the book.
After determining the cylinder is due for requalification, you must obtain a visual inspection report form. To document that every DOT cylinder is properly requalified, you will fill out and file this form. Start by filling in the form with the basic cylinder information. While each company's visual inspection report form may look different, it will include space for you to record the following items: date of inspection, cylinder identification, cylinder serial number, DOT specification or special permit number, marked pressure, actual dimensions of the cylinder, manufacturer's name or symbol, date of manufacture, and owner's name or symbol if present. Type of cylinder protective coating, including a statement as to need of refinishing or recoating. Conditions to check for on the cylinders, for example, leaks, corrosion, gouges, dents or digs in shell or head, broken or damaged foot ring or protective ring, or fire damage. Cylinder disposition. Return to service is indicated on the form with OK. Rejected, removed from service. Hold for repairs is indicated on the form with R or RM. The reason for the rejection must also be documented. Scrapped, condemned is indicated on the form with SC. The reason for the condemnation must also be documented. Legible identification of the inspector. If the cylinder to be requalified contains liquid propane, it may be required to be emptied or evacuated before proceeding with the inspection. Identify which cylinders need to be evacuated. Only evacuate a cylinder if you have the appropriate equipment and you are trained to do so. Contact your fuel supplier if you are not qualified or do not have the equipment to evacuate a cylinder. Attempting to evacuate a cylinder without the appropriate equipment and training can create a hazardous situation.
All right, let's go to page 36. We're going to take a look at a visual inspection report. There's one here. I suspect you can make up your own or, go to any number of online facilities. So again, the first thing you're going to do, take a look, obtain that visual inspection report form. We talked about all of those things that it will have: date of inspection, cylinder identification, okay, and every permit number, mark pressure, all those things that we talked about that are on the collar, okay, type of cylinder protective coating, including a statement as to the need of refinishing or recoating, conditions to check for cylinders, leaks, digs in shell or head, cylinder disposition. We talked about it's either okay, right, it's good to go, rejected, removed service, hold for repairs, and the reason that it was rejected, and scrap, dock, condemned, indicated on the form the reason for the condemnation as well, and try to be as legible as possible. Let's talk a little bit about cleaning and preparing the cylinder, and then we're going to go back to the book.
To properly clean and prepare the cylinder for inspection, you must make sure that you are working at a safe distance from flammable liquids and combustible materials. Remove the cylinder sleeve if present. Remove any rust, scale, caked paint, or other foreign matter from the exterior surface of the cylinder. Remove any coating, rust, or scale from welds and joints where any part is joined to the cylinder body. Mark any area of the cylinder where a dent, dig, cut, corrosion, or fire damage is evident. Use chalk or another non-permanent marking device.
Okay, let's talk about preparing the cylinder for inspection. Remove the cylinder sleeve. If present, remove any rust. We talked about or paint, because it could hide some of the issues with the cylinder. Wear some, okay? Make sure you're working a safe distance. We know to keep away from flammable materials. We know that we want to remove the sleeves, and we want to pay special attention to welds and things of that sort. Okay, we're going to look for fire damage. We're going to look for obvious things. Okay, let's go and take a look at page 38. We're going to do a check for understanding. When preparing to perform a requalification inspection, you must, what must you do? A, remove any rust, dirt, or cake paint from the surface cylinder. You must also obtain a visual inspection form. Determine the requalification date. So let's talk about performing inspections on a steel cylinder. And look now, we're on page 39, where we're taking that piece of that big decision tree and we're just focusing on inspecting. For obvious reasons, this is the biggest part of the process because it has all of the parameters that you will need to inspect. And as we look through this part, as we study this, we take a look to see the decision tree. Is there fire damage? Yes. Can the cylinder be requalified? Well, can it? We're going to talk about that. Either reject it or condemn it. Is there fire damage? No. Cylinder distortion, more than 1%. We'll talk about how we do that. Can the cylinder be repaired or requalified? Then you make your decision. As we mentioned earlier, sometimes for financial reasons, you're better off scrapping the cylinder because it could be too expensive, right? Say excessive fire damage, a volumetric expansion test or water jacket method can be fairly pricey. So a lot of folks like, the fire damage is so extensive. I've got a number of them in my yard, and it'll be cheaper for me to just purchase new cylinders. As we go down, are there damage to valve openings? Yes. Well, when we determine, can it be requalified or repaired? Damage to attachments. Can the cylinder be repaired or qualified? Are there significant dents? Are there any dents on a weld more than 1/4 inch deep? We'll talk about how you figure that out. More than 10% deeper than the greatest diameter of the dent. So those are the parameters for indicating whether or not dents need to either be requalified or have the cylinder scrapped. Significant cuts, gouges, or digs, we'll look at an LP gas cylinder damage limits table, and we'll use that as an example of whether or not that meets that parameter. Significant isolated pitting or line or general corrosion. And this is a tough one, because corrosion, is it surface corrosion? Is it surface rust? We'll look at a table, and this is where we pre-weigh the cylinder and post-weigh the cylinder to see or not there's significant diminution of the cylinder, meaning as enough steel kind of sloughed off of it because of the significant pitting and things of that sort, where there's just not enough metal that we're feel comfortable enough refilling that cylinder without it being requalified. Okay, so we'll take a quick video look at performing inspection on a steel cylinder. We're just going to talk about fire damage now, and then we'll go back to the book.
Perform an inspection on a steel cylinder. Inspect the cylinder for fire damage. Regulations state that a cylinder subjected to fire shall not be placed in service until it has been reconditioned properly. Typically, exposure to fire is normally determined by visual examination with attention paid to the condition of the protected coating as outlined in C6. If there is evidence that the protective coating has been burned off any portion of the cylinder surface, or if the cylinder body is burned, warped, or distorted, assume that the cylinder has been overheated. But if the protective coating is only smudged, discolored, or blistered, and is intact underneath, the cylinder is not considered affected within the scope of this requirement. However, if there is significant fire damage, contact your fuel supplier. Some companies may reject fire-damaged cylinders and send them out for testing, repair, and requalification. Others may choose to condemn cylinders in the same condition. The only way to requalify a steel cylinder subjected to fire damage is by volumetric expansion testing using the water jacket method. If your company sends cylinders out for this type of testing, reject the cylinder, noted with R or RM on the form, because of fire damage if any of the following are present. Valve is burned or melted. Paint or protective coating is burned or charred. Cylinder body is burnt, warped, or distorted. If your company does not send fire-damaged cylinders out for water jacket volumetric expansion testing, a cylinder showing any of the rejection criteria listed previously must be condemned and noted with SC on the form rather than rejected.
Right, and remember, like I said, a lot of employers, managers will say, I'm just going to destroy it. They will condemn that cylinder and destroy it because financially it just doesn't pay to do the water jacket expansion method. Doesn't mean you can't do it, just become a financial decision. So we talk about fire damage to cylinders, and it happens a lot. And we want to look for things like charring or burning of the paint, other protective coatings, burning or scarfing, or when we say scarfing, it's kind of like gives it a really nasty texture to the cylinder of the metal. Has it distorted the metal or the cylinder, or burned, melting off of the valves? Now, friends, I know we have all seen cylinders that should not be in service. What are there, 60 million cylinders out there? There's plenty of them that shouldn't be out there. Again, you're the first line of defense to try to ensure that does not happen. So to ensure that paint is not damaged, wash off the soot, right? We talk about cleaning, we don't know. Maybe it's just some soot on it. Look for excessive distortion, bulges, is it leaning? If the cylinder doesn't show any significant evidence of fire damage, then you'll go to the various next step in the requalification process. And that you're going to do that based on your company policies and what it says here. So, got some fire damage. Can the cylinder be requalified by water volume expansion test? Remember, if there's fire damage, it must be requalified. If it's going to be requalified, using a water jacket method, also known as a volumetric expansion test. Just moving on, I'm following the book. We're on page 42, rejection criteria for fire damage. Okay, we mentioned the only way to requalify a steel cylinder is by the volumetric expansion test. If your company or if you send the cylinder out for this type of testing, reject the cylinder because of fire damage if there are any of the following: valve is burned or melted, paint or protective coating is burned or charred, cylinder body is burnt, warped, or distorted. You reject it, and then you make your decision as to whether you want to have that requalified by the water jacket method, or you're just going to condemn it, and mark it as such on your form, and then proceed to step 4 in the decision chart, which is process. What are you going to do? Well, the process is going to be, we either removed it from, we either rejected it, and maybe we will have it recertified or requalified, or we're just going to scrap it. So if you don't send it out for water jacket test on a situation of extensive fire exposure, you gotta trash it, condemn it, and mark it as such as well. Let's go now to another check for understanding on page 44. You are requalifying a cylinder and are at a point of inspecting for fire damage. Check the list, check the items in the list below that may indicate there is fire damage. Well, let's go for the bottom. Bubbling cylinder coating. Yep, that's pretty much a sign. Anytime there's bubbling, there's fire. Blue-black discoloration of the metal. Yep, that'll do it. Hand wheel is warped. It's possible. You can have fire damage that is warping that hand wheel. Now you can have a warped hand wheel without fire damage. So that's a possibility. But also that the packing seal and soft valve seal are decomposing. That could be a sign of fire damage as well. That could happen without fire damage, but those are some signs that you have fire damage. Mostly you'll see bubbling cylinder coating, black or blue discoloration of the metal. Moving on, we're going to now look at cylinder distortion. Again, we're going to our chart. We just looked at fire damage. Now we're going down the decision tree to look at cylinder distortion, leaning, and valve opening damage. We're going to look at this video shortly and then go back to the book.
If the cylinder shows no evidence of fire damage, check to see if the cylinder is distorted. Determine if the cylinder is distorted to the extent that it no longer supports itself or has bulged in one or more areas on the body. Cylinders that have visible distortions or bulges must be removed from service. If you are unsure if a bulge is within acceptable limits, consult with your supervisor or contact your fuel supplier. Cylinders with more than 1% distortion must be scrapped or condemned. Cylinders in this condition may not be rejected and repaired. Use the measurements to determine if the cylinder distortion exceeds 1%. Check whether the cylinder is leaning. Place the cylinder on a solid, level base. Position it in the same manner as it is when in service. Check the cylinder for excessive leaning due to a damaged or distorted foot ring. If the cylinder is leaning to the extent that it could easily tip over, it must be either rejected, removed from service, or scrapped or condemned. If the damage can or will be repaired, reject the cylinder and proceed to processing. If the cylinder is leaning and cannot be repaired in this condition, then condemn the cylinder and proceed to processing. Determine if there is damage to the cylinder valve openings or neck. Stationary and motor fuel cylinders usually contain more than one opening. In either case, check all valve openings for damage. To complete this step, visually check for cracks, folds, and other flaws in the neck or area where the valve openings are joined to the top of the cylinder. Check the neck or valve opening for general distortion. Where applicable, check for stripping, cracking, corrosion, and chipping of the male threads used for mounting the protective cap to the cylinder. Cylinder neck threads are examined whenever the valve is removed from the cylinder. Cylinders have a specified number of full threads of proper form as required in applicable thread standards. Acceptance criteria for continued use of the cylinder threads require the following: at least 5 continuous full threads for tapered threads on propane cylinders. No visible cracks in the threads or adjacent visible areas. No visible damage from corrosion or other sources that might adversely affect the structural integrity of the threads or valve installation. Cylinders manufactured to a specification with less than the previously mentioned number of threads need to retain all threads in a full, continuous, undamaged condition for requalification and/or continued service. If the cylinder shows damage to the valve openings, your company may choose to reject, remove it from service, and repair cylinders in this condition, or simply scrap, condemn them. Reject or remove from service the cylinder due to valve opening damage noted with RM on the form. If any of the following are present and the cylinder may be repaired: the neck or valve opening is noticeably tilted or sunken, the neck or valve opening is cracked, scrap or condemn the cylinder noted with SC on the form due to valve opening damage if any of the previous rejection criteria are present and the cylinder will not or cannot be repaired.
All right, so there's a lot to this, isn't there? And that's why we're here, and that's why you folks are professionals. Okay, cylinder distortion more than 1%. Now, if there's anyone listening to my voice, watching this, that could tell by looking at this, or looking at, well, maybe this one, but looking at a cylinder that the cylinder distortion is more than 1%, then you have incredibly valuable skills. Absent that, what we're going to do is we're going to measure some of those distortions. So how do we know whether or not something is distorted or not? You're going to look on page 46 and 47. If you can't retain the information or really get your arms around it right now, it's very straightforward right here, okay? We know that cylinders that have visible distortions or bulges have to be removed from service, full stop. If you don't know, you contact your fuel supply, which is probably those folks here. But what you want to do is with a 6-foot minimum tape measure, measure the halfway tape measure and mark halfway between the top of the cylinder and the bottom of the cylinder. Draw a line around the cylinder at the mark. If you can use the waste seam, that'd be great. Measure and record the distance from the center of the cylinder to the service valve, right? You see from here now to here. We've measured from here down to here. We've gone halfway. We marked it. We've done the same thing from here to the service valve to that halfway mark. Repeat this step 3 times, right? So you've got 3 various marks. Measure and record the circumference halfway between the mark and the face seal. Between here, right where the top, and here. Repeat the step on the rest of them. So let's use an example. We can see the example right in your book. Measurements of 16 inches, 16.4 inches, and 16 inches. There's a difference of 0.4 inches. We marked from valve to the center. We've done it 3 times. We're counting. We're now going to measure. And right here we have a difference of 0.4 inches, which is 1%. Right? How do we measure that? 1%. 16 inches is 0.1% times 16 is 0.16 inches. Right? What I'm doing is, what is 1% of 16 inches here? 1% is 1.6 inches. We know that in one of the measurements, we had 16.4 inches. In this example, the difference of 0.4 inches is greater than 0.16 inches, which is greater than 1%. Therefore, the cylinder is out of tolerance, must be condemned. Got to condemn that one. So again, we're taking 3 measurements. Right? First, we're going from the top of the cylinder to the bottom, measuring the circumference. That's the halfway point. Hopefully the waste seam. we're doing that 3 times. We're marking. In the example, we're now measuring where you marked, and we're taking the difference in that measurement, which is 0.4 inches. Remember, if it's greater than 1% differential, it's got to be condemned. Okay, guys? There's another example which we'll show. You could also do it where you're coming around this the other way, where you have now 55 inches, and 55.1 inches. Okay, you've done that. You've measured the differences. The only difference you have now is 0.1 inch. Before, you had a difference of 0.4 inches among the 3 measurements. 0.1 inches, we've got 55 inches. 55 inches times 0.01 is 0.55. In this example, the difference of 0.1 inch is less than 1%, which is 0.55. Cylinder leaning. Again, we're going through the decision chart. We're going down each one at a time and making that decision. Cylinder's kind of leaning. It's probably, faulty foot ring on the bottom. Can it be repaired or requalified? Reject cylinder report, condemn cylinder. Those are the decisions that you'll have to make. Place the cylinder on a solid level base. Position it in the same manner as it is when in service. Check the cylinder for excessive leaning due to damage or distorted foot ring. Excessive really is a something that you can't really measure. I think it's a lot of common sense. It's a lot about being a professional and doing this. To me, this looks like excessive leaning, okay? I mean, if you could just tap it and it falls over, it's probably excessive. And I think we know what excessive means. If the cylinder shows excessive leaning, you can either reject it or condemn it. These are all the criteria you're going through. If we look on page 49, we're talking about damage to valve openings. This is the issue that happened with the Philadelphia food truck explosion, that later the two ladies succumbed to their burns. They died. Apparently the valves were just in such bad condition. The whole thing was rusted out. So again, you may want to say to somebody, say it's a refill operation that you're operating. You have a dispenser on site, or you're teaching your dispenser operators or third party that you deliver propane to. They've got to look at these things. I mean, they just have to look at them all the time, and it's a real challenge. Okay, when we talk about neck, right, refers to the service valve opening in the cylinder. Okay, right in here. Stationary motor fuel cylinders contain more than one opening. Check all valve openings. Check for cracks, folds, other flaws in the neck. The valve openings are joined to the top of the cylinder. Make sure that they're good to go. Check the neck and valve opening for general distortion. Some of these things you do very quickly. And where applicable, check for stripping, cracking, corrosion, chipping of the male threads used for mounting the protective cylinder. Right? I want somebody to take care of my family and check these things if I'm going. Damage to open valve openings. All of these threads. Examine those threads. At least 5 continuous threads must be in good shape without any cracking or visible damage. No visible damage from corrosion or other sources that might affect the integrity. Why? Well, it's a great place to have a leak. Right? If you got damaged threads, it's a great place to have a propane leak, and that will be problematic. Face seals. Just recently, NFPA says you have to inspect face seals. I think, once again, this is just my opinion, which I have many of, that the manufacturers of propane cylinders, perhaps they can use a better piece of material for the integrity of these face seals. But the onus is now on you to check those face seals. And I'm talking about the O-rings right in here. And this one, right, it's pretty good shape. If we look here, you can see some damage here. Again, we're looking at the seals, the O-ring. And here, remember the Challenger? The Challenger spacecraft blew up because of a faulty O-ring. Sometimes it's the little things that could really ruin your whole day. Valve openings, damage. Okay, we're now looking, can the cylinder be repaired or requalified? You've looked at some of those things. You've looked at those openings. Can we repair them? Rejection, contamination, condemnation criteria for valve openings. Right? This is when we go to the process. That's where you'll put in your process report. in your report, the various process. That process is the last step, requalify or condemn. Not only if the neck is a little damaged, but what if it's kind of sunken in or receded into the cylinder a little bit? That also needs to be set aside. And again, it'll be a financial decision whether or not it's sent out for requalification or whether or not it's condemned and scrapped. On page 53, we have another check for understanding. The term neck refers to the service valve. Service valve opening in the cylinder that contains only one top opening of the service. Now, friends, I have no problem going over these with you and just giving the answers, and we'll do that at the regular quiz, because this is really not a test for certification. We never do this in a CTAP class or a test for formal certification. So I'm doing this just so we speed things along. If we were in a classroom setting and had more time, I'd probably be doing this at a bit slower pace. But I'm a big believer that as much as I like computer-based training, you can really sit at it for just so long. So we're going to get you what you need, and hopefully you'll do your own due diligence and go through some of this information as well. Let's look at a quick video on cylinder attachments. We're on page 54 of the book. We'll look at this quick video, and then we'll go back to the book.
Next, identify if there is damage to the cylinder attachments. Cylinder attachments are parts that are welded or brazed to the cylinder body for protection, installation, or identification. Typical cylinder attachments are collars, foot rings, and supports. If a double or false bottom is present on the cylinder, it has been tampered with and should be removed from service immediately. Check all cylinder attachments for serviceability. Do the following checks. Inspect the collar. Look for distortion or damage that would limit or prevent it from protecting the cylinder valves. Look for corrosion or cracking where the collar joins the cylinder body. Next, invert the cylinder and inspect the foot ring or supports. Look for distortion that would prevent it from supporting the cylinder properly in an upright, stable position. Look for cracking or corrosion where it joins the cylinder body. If the cylinder shows damage to the attachments, your company may choose to reject or remove from service and repair cylinders in this condition, or simply scrap or condemn them. Reject or remove from service the cylinder noted with RM on the form due to cylinder attachment damage if any of the following are present, and the cylinder may be repaired based on your company policy. The collar is loose or shifted, damage to the extent it cannot protect the cylinder valves, or weld points are damaged or cracked. The foot ring is loose or shifted, damage to the extent it cannot support the cylinder in a straight or upright position, or weld points are damaged or cracked. Scrap or condemn the cylinder noted with SC on the form due to cylinder attachment damage if any of the rejection criteria above are present, and the cylinder will not or cannot be repaired based on your company policy.
Okay, now again, it's a lot to go through. Some of these things are a pretty quick look. I mean, it'd take you a short period of time to look and see whether those attachments are damaged or not. So I never knew that there were sometimes false bottoms to cylinders. And if there is a false bottom, it means it's been tampered with. Maybe somebody is trying to get something across the border that they shouldn't. But I've never encountered that. But apparently it is a thing that you may encounter. So we look at cylinder attachments for serviceability, inspect the collar, distortions or damage that would limit or prevent it from protecting the cylinder valves. We know how critically important it is to keep those valves protected. Look for corrosion or cracking where the collar joins the cylinder body. Look for a change in position of the collar relative to the original position at the time the collar was attached to the cylinder. So it could happen sometimes is, when we look at this position or things get bent, it's kind of like I like to use the example of a paper clip. You can bend the paper clip a lot of times, but sometimes the last time you bend it, it breaks. Kind of like us. And the older we get, we can bend a lot, but then we've certainly got to be careful. Same thing with some of the integrity on some of these things. I mean, you think about the wear and tear these cylinders go through. We'll talk a little bit about stationary cylinders at someone's home where the process is not so vigorous, because the thought being is, they're not thrown around, a lot. They're not, they're pretty much where they are. Some of these cylinders really go through an awful lot of abuse that can cause damage. Now, invert the cylinder. Look at the foot rings. Distortion. Are they all rusted out? Change of position relative to the original position. You know what I'm talking about. We don't got to spend a whole lot of time on that. And then you're going to go back to the chart to make a decision on the process. Can the cylinder be repaired or requalified? And you will be saying this, I suspect, in your sleep. To make the decision to reject cylinder, mark in the report RM, right? Continue to that process where you're setting it aside. Condemn the cylinder, mark in the report SC, continue to that process where you're going to mark that cylinder appropriately and set it aside in a safe place. So you can see it's a redundant kind of thing. It's a matter of getting you to use the book, and we're going to use some of the tables even a little bit more. On page 58, we're going to have another check for understanding. Okay, the question being, what's the proper answer? To inspect the cylinder foot ring supports, you must empty the cylinder. No, you don't have to do that. You have to invert the cylinder, just as we just mentioned just a little while ago. We're going to go about another 20 minutes or so, or maybe less, and then we'll probably take a very short break. All right, now we're looking at dents. We've looked at fire damage. We've looked at valves. We've looked at a number of things. We've looked at leaning. Now we're going to look at dents. We're going to show a quick video, and then we're going to go back to the book.
If the cylinder attachments have passed inspection, check to see if the cylinder has any significant dents. A dent is an area of the cylinder that is deformed or pushed in by colliding with a blunt object. Typically, a dent does not reduce the thickness of the metal. It could if the dent is deep and confined to a small area or is near a weld. For these reasons, dents in the cylinder must be measured and checked carefully. Cylinders that have dents that meet or exceed the following conditions are considered out of tolerance, are on a weld and more than 1/4 inch deep, or are not on a weld where the depth of the dent is greater than 1/10 of the greatest dimension of the dent, or exceed the maximum allowable dent depth for the average diameter as shown in the chart Maximum Depth of Dents allowed for DOT and ICC cylinders. If you discover that any of the dents are out of tolerance based on your measurements, scrap or condemn the cylinder and proceed to processing. Cylinders with dents that are out of tolerance may not be rejected and repaired. They must be condemned. Refer to the minimum allowable design thickness table in the book.
All righty. So, a dent's a dent, right? But some of them are allowable and some aren't. So, what you want to do is, when a dent is detected, you want to obtain 2 carpenter or metal straight edge rulers, locate the dent. Check if the dent includes a weld. Use a straight edge to measure the overall diameter dimension of the dent. Measure the dent depth to the nearest 100,000th of an inch using an industrial depth gauge. You may have some of those, and there are now digital ones as well. I've never seen one, but I'm told that there are. And record the greatest dimension of the dent and depth. On page 60, you will see your damage limits for cylinder dents table. Right? This is what we're looking at. We've got something like this. We want to measure those dents. We want to measure the circumference. We want to measure the depth. And then from that, we will determine whether it is acceptable or within various limits. We'll do some learning activity on that. Now, of course, if there's a dent on a weld, that's more significant than a dent elsewhere for obvious persons. The weld is a weaker part of the cylinder, so we want to pay special attention to that. Okay, so if there's a weld that's more than 1/4 inch deep, the weld, and it's not on a weld where the depth of the dent is greater than 10% the greatest dimension of the dent or exceeds allowable limits of the dent. We'll all pick that up in this chart. And then you will also, once you do that, you will go to your process. Let's go to page 62, okay? This is a learning activity, and we're going to refer back to the chart on page 62. Again, if we were in a classroom, had more time, I'd say do this on your own. We'll get back to it. We'll talk about it. But let's just do it together, all righty? So, number one, a steel cylinder has a dent that is not on a weld, but could be out of tolerance for requalification. After measuring, you find that the dent is 0.35 inches. The average diameter of the dent is 2.78. Now, we know that information. We go to our chart and we take a look. The average dent diameter, as we have looked at, is 2.78 inches. We go down, we're on the far left of this chart. We go down, down, down to 2.78. The maximum allowable dent depth, which is not on a weld, is 0.29 inches. But what we have is the average dent depth here is 0.35. So we went to the chart. We saw first what we did is we measured the diameter of the dent at 2.78. We did the dent depth at 0.35. We went to the chart. We looked to see what is the maximum dent allowed on a chart based upon a dent diameter of 2.78 inches. And we came up with 0.29 on the chart. But as we measured the dent on the cylinder, it was 0.35. So it must be below 0.29. This is above that, so it cannot be requalified. It's just a matter of looking at what you have measured and then going with that against the chart. A steel DOT cylinder has a short dent. After measuring, you find that the dent depth is 0.14 inches, right? We're not on a weld here, 0.41 inches. The average diameter is 1.5 inches, right? You measure that, the diameter is 1.5 inches. The dent depth is 0.14. You go to your chart on page 60, you look at 1.5 inches, right, on the average dent diameter, and the maximum allowable dent depth is 0.15. Well, what do we have? We have 0.14. 0.14 is less than 0.15, and so you are good to go. You can requalify that cylinder. Let's look at another example. A steel DOT cylinder has a dent on the weld. After measuring, you find that the dent depth is 0.28 inches. The average dent diameter is 3.1.4 inches. You don't need to go to the chart on this one because if it's on a weld, it can't be more than 1/4 inch deep. Okay, but let's just take a look anyway, right? On a weld, doesn't matter how the diameter of the dent, any dent more than 1/4 inch deep cannot be requalified. This is a good exercise to follow. If you're not grasping it 100%, I would suggest you go and look at the learning activity on page 62 and refer back to the chart. And you can see the various pictures back and forth. It shows where it's at. And I think after you do it a couple of times, if you don't already have it cold, you certainly will. We're going to go to a video clip. We're going to now look at cuts, gouges, or digs, another criteria of your rejection, requalification, or condemnation. We'll look at the video, short video, and we'll go back to the book.
Check the cylinder for significant cuts, gouges, or digs. A cut, gouge, or dig is an area of the cylinder that is deformed or distorted by a sharp object. Typically, the wall thickness is reduced and weakened at this point. Based on your measurements and the damage limits shown on the LP gas cylinder damage limits table, you must consider whether any of the cuts, gouges, or digs are outside of the specified damage limits. If you discover that any of the cuts, gouges, or digs are outside of the tolerance based on your measurements, scrap or condemn the cylinder and proceed to processing. Cylinders with cuts, gouges, or digs that are out of damage limits must be scrapped or condemned. They cannot be repaired.
So, just like we saw before, we've got a chart on page 63 that gives the minimal allowable design thickness based upon various specifications as it applies to the cylinder. Let's go through some of those things. All right. So, if you want to have a pit gauge, you can also have them electronically or digitally, if you will. Okay. Let's say you want to make sure that it's not these pits are not excessive tolerance because it could weaken the steel. Weakened steel is problematic. Of course, we're having product under pressure. Again, Carpenter's rule or industrial depth gauge. Locate the cut, gouge, or dig on the cylinder's body. As you can see, we're right in there. Okay. You're going to measure the overall length of the cut, and then you're going to measure the depth of it with a pit gauge, as we've shown here. Right. So let's say we have the pit gauge here. This here is representing this cut and the depth of that cut. You put your pit gauge inside where that gouge is. Here's the original thickness. There's the gouge. You're going to measure that up against the original wall thickness. This is a perfect example, ladies and gentlemen, of some of the things that I would definitely do from a hands-on training or just kind of a hands-on refresher for yourself. Actually do these things if you've not done them before, or even refresh yourself on doing before, looking to get your RIN number. And we can look at this. We have a pit right here. Look on the cylinder bottom. It's the same way. You measure it across, and you'll measure using the pit gauge the depth of that cut, gouge, dings, or pit. Once again, are there any cuts, gouges, or digs outside the LP gas cylinder damage limits table? Well, if there are, we got to do something about that, right? We're going to look at that table. Again, we'll look at that on page 66, which we see in front of us, and that will determine whether or not we're in tolerance or not. Okay, so once again, the cut, gouge, or dig is less than 3 inches long and deeper than the dimension shown in column 1 of the chart. The cut, gauge, or dig is more than 3 inches long and deeper than shown on the chart of column 2. Cylinders were cuts or gouges or digs that are not within limits cannot be repaired. They must be scrapped. So let me say that again. If you discover that any cuts, gouges, and digs are out of tolerance based on your measurement, you have to scrap it. Scrap the cylinder, proceed to processing. Specifically, you have to scrap or condemn the cylinder if the cut, gauge, or dig is less than 3 inches long. You're going to measure as I've shown you using a ruler, then a pit gauge. You do the same thing for pits here. You're going to take a look at this table. Is it out of compliance? Is it out of those damage limitations? The cut, gauge, or dig is more than 3 inches long and deeper than the dimension showed in column 2 of the chart, then you are out of compliance. So it's all about following the chart. So if you have a cylinder, a 20-pound cylinder, you have a specific ICC code. It's a steel cylinder. It has water capacity. It has all the original thickness, all of those things, and it'll give you the tolerance limits of what you can actually requalify based on pits. But if there's longer, if the cut, gouge, or dig is less than 3 inches long and deeper than the dimension shown in the chart, you have to scrap it. If the cut, gouge, or dig is more than 3 inches long and deeper than the dimension shown on the chart, you have to scrap it. So 3 inches is what you want to look for. If it's less than 3 inches, it'll have a specific criteria. More than 3 inches, it'll have a different criteria. That's what you want to look at. And it'll say all of those things right across the top of that chart. On column 1, whether it's less than 3 inches, column 2, we'll talk about line corrosion, isolated pits. We look at completely page 68, select the tools required for damage cuts from cuts, gouges, or digs. Well, we're looking at a carpenter rule. You don't want to use a rubber mallet, and you want an industrial depth gauge. Okay, you guys all with me? You feel like you're slowly bleeding to death yet? We'll have opportunity for questions. If your phones are open, you can ask them now. Now, friends, I just want to take a short break. I take short breaks, and I like to use a little humor. I want to, before we do anything, I want to really wish you all a happy and safe Thanksgiving. And you'll notice that I have a happy Thanksgiving from the fire service. The fire service is always busy on Thanksgiving. Why? Because there are lots of people that want to deep fry their turkey, and some of them are idiots. Now, I don't know about you, but it's amazing that this stuff happens every year. So before we take a break, I want to have just a little bit of humor here and some turkey fryer fails. I love this no insurance for you. And let's see what these geniuses are up to.
Oh my God!
Yeah. Whoa, boy!
Dirt, yeah.
That's you want to try the baking soda first, because that's what they tell you in biology.
That's what they tell you in biology, baking soda. Look at this guy. He's still trying to put the bird in, and his house is lighting on fire. Come on, man.
Don't just drop it quicker. That's
Look at that. I just throw that bad boy. There we go. That's right.
Whoa!
Okay, ready? We're going to fry turkey now.
Another genius.
Kirk, you're burning the house!
Burning the house down. There you go. That's right. Now, friends, I don't know, maybe I'm being kind of a snob, but it seems to me you should be able to determine whether or not you'll have too much oil in that thing before you put the bird in. Anyway, I have got 11:30. I should have 11:31. Let's take 5 minutes. We'll be back at 11:36 sharp. And we'll talk about isolated pitting, line corrosion, and general corrosion. I know you don't want to miss that. Isolated pitting, line line corrosion, and general corrosion. And as we've been doing, let's start with a short video and go to the book.
The next step is to inspect for any significant evidence of corrosion on the cylinder. Corrosion or pitting in cylinders is a serious problem that results in the loss of wall thickness of the metal. The potential for a cylinder to fail may be related to corrosion in areas that are not readily visible, as in the case of isolated pitting. Corrosion that could cause a cylinder to fail may not be visible without close inspection of all areas of the cylinder. Dirt, paint, or rust can potentially cover an area of isolated pitting. This is part of the reason that the cylinder must be cleaned before you begin the inspection. You must make sure to check the bottom of the cylinder inside the ring for corrosion during your inspection. This is the area of the cylinder that is most likely to get wet, thereby increasing the potential for corrosion. To inspect the cylinder for corrosion, each type of corrosion is identified and measured. Be aware that when there is a cluster of isolated pitting in an area, figure the average depth of the isolated pitting to be twice the depth of any general corrosion. Based on your measurements and the damage limits shown on the LP gas cylinder damage limits table, determine if any of the isolated pitting, line corrosion, or general corrosion is outside of the specified damage limits. If you discover that any of the corrosion on the cylinder is outside of the damage limits based on your measurements, scrap or condemn the cylinder and proceed to processing. Specifically, scrap or condemn the cylinder when any of the following are present. Isolated pitting. The measured depth of pitting is greater than the maximum permitted depth shown in column 3 of the LP gas cylinder damage limits table. Line corrosion is less than 3 inches long. The measured depth of pitting is greater than the maximum permitted depth shown in column 1, line corrosions less than 3 inches long of the table. Line corrosion is more than 3 inches long. The measured depth of pitting is greater than the maximum permitted depth shown in column 2, line corrosion more than 3 inches long of the table. General corrosion. The measured depth of pitting is greater than the maximum permitted depth shown in column 4, pits in the general corrosion area of the table. Cylinders with any type of corrosion that is outside of damage limits must be scrapped or condemned. They cannot be repaired.
Okay. So we're really talking a lot about a similar table that we used on page 66 for cuts, gouges, and digs. The table that you just saw is on page 72, right? So let's go through this just a little bit. So again, we know that cylinders really are involved in all kinds of nasty environments or banged around. We want to look for isolated pitting, line corrosion, which is just what it says, corrosion that's, in kind of a line, either vertically or horizontally. And this all over general inspection. Just like before, we'll get a carpenter's rule, industrial depth gauge. We will measure isolated pitting as followed, as long as there's, and there could be a cluster of pitting as well. So you want to use the depth gauge to measure the depth of the isolated pitting in several places, similarly as we did showed previously. Record the location, such as shell or head, wherever it may be, on a separate piece of paper, and continue until you have measured everything. You want to measure line corrosion using a carpenter's rule. Measure the depth and pitting using the pit gauge. If crevice corrosion is present, use a scriber to measure the crevice corrosion and record the location depth on a separate piece of paper, and then mark in your report as follows. On page 72 is the chart that you saw in the video. Any of those things are out of tolerance, the cylinder has to be removed from the facility. Set aside, cannot be refilled. This is what we're talking about, okay? Corrosion is permanent, damages reduces the walls, and so if it's beyond those limits, you have to condemn the cylinder. And if you look at the table on page 72, across the top, it'll ask you, well, is the line corrosion less than 3 inches long? Is the depth of the pitting greater than X? And it'll just take you right through on that table. So it's really a matter of getting used to using the tools in which to measure the corrosion and the pitting and matching that up against the damage limits for this type of corrosion that we're looking at the table, similarly as we did on page 66. Same sort of thing. We're talking about cuts, gouges, digs, and now corrosion. Outside the limits, it has to be condemned. You get a cylinder in there, some folks, and somebody told me that they like to, they tar over the corrosion. We'll just put a bunch of tar over it. And so it won't look as corroded, or in the foolish thought that it will increase the tensile strength of the cylinder steel. If you ever see that, condemn it immediately. Let's go to page 74. Let's look for a check for understanding. Identify the type of corrosion that is not defined in the cylinder requalification procedure, and that is weld corrosion. Right? We don't talk about weld corrosion so much here. We talk mostly about line, isolated, and general corrosion. As far as welds go, what did we say earlier? that any well that's greater than 1/4 of an inch where the depth is, right? If it's pitted more than 1/4 of an inch, it's being discarded. You can't use it. We talk about this type of corrosion. In this course, we're talking just general. Is it sporadic across the steel? Are there isolated pitting that'll group together? When you have a large group of isolated pitting, that could really cause a deterioration of the steel and may not hold the pressure that's required. And we also want to look at line corrosion. Alrighty, so as we look at line corrosion of the other corrosions, right? When doing a visual inspection reveals a sign of corrosion, the cylinder must be emptied, weighed, according to your company procedures, depending on the scale you have. Now, why do we want to do that? When things are corroded or pitted so poorly, that means that we're removing steel from the cylinder. And too much steel removal is going to compromise the tank so much or the cylinder so much that it's not going to be able to withstand the pressure that is required and can result in a catastrophic issue. So you know what the tear weight is of the cylinder. That's the weight of the cylinder before it is filled. The tear weight on the cylinder will be on the neck ring, TW. You always know where that is. So you have a lot of corrosion. You scrap or condemn the cylinder if the cylinder tear weight is reduced by more than 5%. Okay, so tear weight is 17%. You multiply that by 0.05. If it's reduced by less than that 5%, then you have to condemn it. Pretty straightforward. There's one exception to condemning a cylinder with 5% or more tear weight reduction, and that stipulates that if the weight loss of the marked tear weight is between 5% and 90%, 10% of the loss, the cylinder may be requalified only by volumetric expansion tests, right? So if the cylinder loss is just between 5 or 10% loss, you can requalify it by using the expansion testing. But as I said earlier, that expansion testing can be costly. And so it's often a decision that, if we have a tear weight of, say, 17, and then we weigh it again, and we've lost, maybe it's now 16.5. Now, that's a lot. Loss of steel to requalify that or repair that cylinder is probably going to be more costly than the cylinder is worth. All right, let's look at page 76, Test for Understanding. And again, I'd love to, if we were in a classroom setting or we had more time, I'd go through this one at a time with everybody. That would really put us beyond the 8 ball time-wise. And so I think the way we're doing it now, I think it's working out pretty well. I'm always going to be available for questions or comments or anything else that I might be able to assist you with after this class. On page 76, let's fill in the blank. A cylinder that has lost more than 5% of its marked tear weight should be condemned. However, if it's between 5 and 10%, it can be requalified using hydrostatic testing. As I mentioned, that's often not done just because of the finances of it. Now, friends, we've gone through all of the criteria of the inspection on our foldout. We've gone through what I think is the most critical part, in addition to documenting, to ensuring that your cylinders are pretty good to go. But we've got another one before we decide how we're going to process it, and that's leak testing that cylinder under certain circumstances. So guess what we're going to do? We're going to show a short video, and then we're going to go back to the book.
Test for leaks. After the cylinder has passed the visual inspection portion of the requalification process, the cylinder must be tested for leaks before the cylinder can be requalified. Because of the possibility of a leak, this test should be performed by charging the cylinder with propane vapor. Do not use propane liquid. In addition to the leak test procedures described here, some marketers and cylinder manufacturers may recommend performing additional checks at this point in the requalification process. For example, your company may recommend exercising the actuated valves on the cylinder during the leak test. For more information about additional recommended checks during leak testing, see your company policy or the manufacturer's instructions. To leak test the cylinder, install all cylinder valves and accessories using the appropriate wrench and thread sealing compound. Ensure the service valve is closed. Carefully move the cylinder to a filling station and connect the vapor hose to the cylinder. Carefully open the shutoff valve on the end of the vapor hose. Carefully open the service valve. Charge the cylinder until pressure equalizes. Shut off and disconnect the vapor equalizing hose carefully. If an electronic leak detector is used, operate the detector according to the manufacturer's operating instructions. If a leak detector solution is used, apply to cylinder valve threads, all welded seams, all points where neck and foot rings are joined to the cylinder body, and all areas that had severe corrosion, cuts, digs, or dents. Visually check all areas where the leak detector solution has been applied. Mark any area of the cylinder that is leaking if leaks are found. Bleed down the cylinder carefully. Close the service valve. If a leak was found, secure the cylinder in a safe area and call your propane supplier. If no leaks are found, the cylinder has passed inspection. Mark the cylinder as OK on the inspection form. Make sure you have documented the entire process and file properly.
Okay, so we've gone through all the criteria. We've gone through all of the criteria thus far that is in that fold-out chart in this example, right? And he marked it okay. We had the cylinder requalification date was proper. Fire damage was okay. Cylinder was not distorted more than 1%. Cylinder wasn't leading. There were no damage to valve openings, no damage to attachments, no significant dents based upon our measurement and charts, no significant cuts, gouges, or digs based upon our measurement and the charts, as well as no significant isolated pitting or line corrosion. We went over to the leak process, which is part number 3 in the process, and there were no leaks. We did everything properly. We marked OK on the form, and we are good to go. All right, so again, we're checking for leaks, so we don't want to use liquid propane because it expands 270 times. Who wants to use liquid propane when we're checking for leaks? We always want to charge it with vapor. You know, confirm the cylinder valves and accessories are properly installed. And this is the last part of the inspection process. Ensure the service valve is closed. Carefully move the cylinder to a filling station. Connect the vapor hose to the cylinder as you've been trained to do. Carefully open the shutoff valve on the end of the vapor hose. Carefully open the service valve. Charge the cylinder until pressure equalizes. As you have probably done many times in your career, apply a suitable leak detection solution. This is critical. I mean, it really is critical to do this. On valves, welds, points where necks, everything that you looked at. Now it's the last step. You want to make sure it's no leaking. Visually check everything. If you have an electronic leak detector, use it according to manufacturer's instructions. Mark any area of the cylinder that is leaking. Obviously, if it's leaked, you can't mark OK. You got to fix where that leak is. After all areas of the cylinder have been checked and marked, close the service valve, bleed down, disconnect the vapor equalizing hose if necessary. If a leak is found, bleed down the cylinder carefully before proceeding with any repairs. I mean, really, nobody wants to work on a cylinder that's leaking that has product in it. Determine if the cylinder needs additional purging. Not return. Remove the purge adapter from service valve. Store all equipments. If there's no leak, you'll mark OK on your form and proceed to processing, which processing will mean as we look at our fold-out chart. And once everything is good to go, on our fold-out chart, the process, it's completed inspection, everything is good to go. You can fill the tank. You can tell your customer that your cylinder is fine and everybody's happy. Threaded opening leaks. We're going to take a look at some of these things a little bit more specifically. Leak at cylinder thread openings? No. Is there a leak somewhere else? Again, this is a nice process that you could use. Threaded openings still leaking after resealing and retesting? If that's what happens, set it aside. You can get further repairs, or you can scrap it. And so you want it on your report. You can it's either okay, good to go. Say if it's still leaking, it's not. So you either remove it or you can scrap it. That's the rejection criteria. Now we're going to process the cylinder. We've pretty much done everything. Based upon what we've done, now we're going to make the determination if it's passed inspection and marked okay on the report. Mark cylinder neck collar with the RIN, next requalification date and letter. The cylinder has been rejected and report is marked RM. Note the cause of rejection in your report. Mark the cylinder part or point that failed inspection with paint or waterproof marker. Repair or send for repairs based on your policies. And if there's a leak somewhere other than the threading opening, necessarily, then you have to condemn the cylinder. Well, you have to give it back to the owner and let the owner know that, marking that in your inspection report. So we're just going to say it over again. Okay, it's a pass. It's okay. Right, mark it. You got it. You have to have now. You've got to have your RIN number to do all these things, but you can mark it with that date and with that E. Cylinder has been rejected and report marked RM, as we can see here. Okay, not good. Okay, on this cylinder. We rejected all the other criteria. We've used ditto marks where appropriate. We marked our report on the other criteria. Cylinder scrapped or condemned. Say this one has leaking. We decided to scrap it. Okay, marked SC on the report. We go to page 87. Another check for understanding. If after inspection the cylinder needs to be rejected and sent for repairs before returning to service, which of the following items is not part of the process to reject the cylinder? The cylinder needs to be rejected and sent to repairs returning for service, which is not part of the process, render the cylinder incapable of holding pressure. Okay, we're going to send it back to be repaired. That's all we need to do. We just need to set it aside, mark it as such, and mark that on your report. Special qualifications for cylinders. We're not going to spend that much time on this. I know that manufacturers of composite cylinders, which I think are pretty cool, they're just kind of expensive. Those cylinders will need a special permit for recertification. That's a little beyond the scope of this process, but within the NPGA fact sheet where PHMSA has links, that will indicate that a bit better than what we can go over right now in this class. But basically, you would look at a composite cylinder, you look at some of the things that we talked about, but you will need a special permit. You will need a special requirement to inspect those cylinders. One of the last things that we want to talk about is requalifying aluminum cylinders. You see we have this picture of CGA, CGA 6. We said earlier that PHMSA has agreed that a copy of that book required at facilities doing requalification, as long as you have the manual that you have in front of you. And again, I would download from the link that is in that NPGA fact sheet of that agreement that PHMSA has and stick it in that book too, because you never know. You could have an AHJ or somebody come in there that is unaware that that is okay.
Quick question. So the manual that I've been going by is a little bit out of date. My CGA manual was signed by George Washington.
Wow.
Do they have a requirement to have the most current version or anything like that? Or just, is this copy good enough?
That's a great question. I'm going to guess that the copy is good enough, but I'm guessing that.
I could probably sell it for George Washington's signature and then buy it.
I'll buy it for you for a beer and a sandwich. But what I would do to make sure, and I'm happy to do this, you know, I'd give our friends at NPGA a shout.
Yeah.
I think there's I forget the gal's name, either Mike Calderera or the other gal. She's really dynamite. She'll let you know, and it might be on their agreement, but I believe, again, I'm just guessing. I believe that you do not need the updated version, but I think that should come from NPGA.
Okay.
That would
Thank
be
you.
yes. I'm working with the 2019 edition right now, which I suspect everyone has. That's their most recent. So there's not an edition to my knowledge beyond 2019 at this point. But that's a really good question. But I would ask Sarah that. If we look at cylinder requalification checks for steel and aluminum cylinders on page 91, there is a little bit of a difference of them. As we mentioned earlier, fire damage to aluminum cylinder is immediately has to be condemned. And there are some differences, not a lot. There are some differences between what you use to condemn parameters of a steel cylinder and an aluminum cylinder. And I would encourage you to take a look at that. Some of them are very similar. Dents away from welds is the same thing. The fire damage is the big one. Some of them are the isolated pits. There are some differences on that. Again, when you look at the tensile strength of aluminum being less than steel, makes kind of sense that there would be a little bit of a difference between those two things, between the accommodation of wall thickness, which is acceptable, and those that are not. So remember, if you get aluminum cylinders, and I'm sure you do, right? Get aluminum cylinders, make sure that you take a look at that criteria, and I think that will make it a lot easier for you, especially on things like wall thickness and on fire damage. Other things, again, we talk about minimum allowable thickness for low pressure cylinders, right? Pretty much we're talking about perhaps an aluminum cylinder, but some of them have lower pressure and are used for different criteria. Those also, you go to the chart of a cylinder that uses a lower pressure than your quote unquote normal cylinders. That will also have a specific chart for minimum and allowable design thickness that may differ from steel cylinders. My sense is steel cylinders are the ones that you're going to look for or be looking at. We look at composite cylinders. They're made of fiberglass or some other thermoplastic material. They're lighter, they're kind of cool looking. Cylinders used under special permit issued by DOT must be requalified in accordance with the terms of the permit. 49 CFR driving documents that issue these permits. Specific requirements for requalification of composite cylinders are contained in the DOT special permit. So anyone, if you're using composite cylinders, if you're purchasing them from a manufacturer, get their special permit so that you will be up to speed on requalifying those things. Go to manufacturer's instructions. I'm going to guess that there are not a lot of you that have seen those out there. Okay, we're looking now on page 94, cylinders and stationary service. We're going to talk about that a little, then we're going to talk about motor fuel forklift cylinders. You don't have to verify tear weight on these. Any damage observed that meets or is more severe than the rejection limits, the cylinder must be removed from service. The reason, again, not so much for the tear weight, it's probably not going to get banged around as much. but you will do everything else as you have done a non-stationary cylinder. If any damage is observed that meets or is more severe than the rejection limits, the cylinder must be removed from service permanently. Can't repair it, right? That's the other issue. Remove it. Motor fuel, forklift cylinders, OPD is not required for engine fuel cylinders used on industrial trucks. Horizontal cylinders exempted from the OPD requirement have to be marked. Probably, hopefully they come in that way, or if you sell them that way, then you have to be mindful of that. Pressure relief valve must be replaced with a new one within 12 years of manufacturer's date and 10 years afterwards. Not required to have an OPD. If the OPD is not present, the cylinder must be labeled to indicate this. Pressure relief valve discharge must be directed upward within 45 degrees vertical. I don't know how much you have to be bothered by that, but these are things to know for folks that are filling cylinders. The manufacturer should really take care of much of these other things. I think one of the more important things is that you cannot exchange a forklift cylinder for an engine fuel cylinder, okay? They often look similar, made of aluminum, left-handed threads. They often have a little green paint on the top. That will indicate that they are not interchangeable with forklift cylinders. Last check for understanding. NFPA 58 allows composite cylinders to be used for propane service under a special permit issued by DOT. We know that that's true. I'm going to go through a summary, and then we're going to go through a quiz. But before that, you just can't make some of this stuff up, friends. I have found in my almost 19 years being at PERC, and the reason that you have to document things is because people do things that you can't believe that they do. So let's take a look at this one.
Bradley County deputies pull a minivan over Tuesday night. It's just the beginning of a bizarre story. Deputies spotted the van traveling along Spring Place Road, and as you can see, it was easy to spot. An oversized propane tank weighed down the van, nearly dragged it to the road. County Fire Chief Dewey Woody says the driver hoisted the tank into the van by removing the passenger seats. He then used a chain that was attached to the steel base where the seat was fastened on the floor. Deputies say the tank's valve sprung a leak when the driver dragged it into the van. So to stop that leak, the driver plugged the hole with a golf tee. Firefighters quickly stopped the gas leak and made sure the man got a trailer to haul the tank away safely.
All right, he stopped it with a golf tee. I know he got that, but it's a good thing Sheriff Dewey Woody, who I want that name.
Stu, wasn't he supposed to use saddles when he transports that?
I'm gonna have him call your company.
Okay.
But these, yes, you're right. But these things happen, and again, not to put too fine a point on it. I've been in depositions. I've worked with people do things that are just, you gotta shake your head. It's not saying, well, they're just stupid. I want to replace my propane stove with an electric stove, and I'm going to do it myself. I didn't cap the line. My trailer, I'm doing that in my RV. It blew up, and now I'm going to blame the guy that filled my RV tank because he didn't tell me not to do dumb stuff. It happens a lot, and I bet everyone on this call knows that. And so, yeah, you can't make this stuff up. There actually is a part one, but that was one where a guy burned his house down using a propane torch to burn the fur off of his squirrel that he was going to have for dinner. It really happened. But folks do really incredibly dumb things. And if you don't document those reports, apologize if I sound like a broken record, then it could come back to bite you. If someone is stupid enough to do what that guy did, people do even stupider things.
And Stu, we put a question in the chat a little while back about one of our guys has condemned cylinders before for customers, and the customer has insisted on taking the cylinder back with them.
Yeah.
What do we do with that? And I told him as long as we document it, I mean, customer owns the cylinder. You can't steal it.
Yeah. That's my opinion of it as well, because of what you just said. And that's a good question. It's asked a lot. The customer owns the cylinder. You know, you're not law enforcement. You can't, it's not like, well, Mr. Flatow, I'm gonna take your car now because you're too drunk to drive, which believe me, never happened. But you know, you have to, you know, I mean, take a picture of the darn thing, get the customer's name. I mean, you really want to document that, because I guarantee you he's going to go somewhere else. Now, I know what some companies do to make sure that people are safe is that they will give them one of their cylinders either for free or at cost.
I've actually done that before.
Yeah, and you know what? I think doing it at cost is fair. Doing it for free, this is my own opinion. 2, you've removed the safety issue there. Completely removed it. Remember, we're professionals. B, if I were your customer and you did that for me, I'd be your customer for life.
Mm-hmm.
And I might even, you know, put something on social media that says, you know, and so it's just like, you know, I liken it to some marketers will say, you know, I'll say, what do you do if someone says they smell gas? And some will go, and most will go, we go out there right away. If they own the tank and they can't pay for a leak check or inspection, we'll do it for free because they supplied the gas. Well, for whatever reason they were called. I think that's a bold, professional move that really highlights in many ways what the propane industry is about. And so it's a business decision. My guess is it doesn't happen a lot. If it were Flatow Propane and it was a customer that, you know, I kind of knew, I might at minimum give them a new one at cost and explain why. But no, you can't take it away from them. You just can't. And I bet some of your team and some of you folks on the line, whether you do this or not, might have experienced some angry customers that say, I can't refill your cylinder. It needs to be communicated to company policy what that process was going to be. Whether it's a Lowe's, whether it's your own company that also has a dispenser on it, or whether it's customers, it's something that you may, you know, want to communicate and what that policy is. Great question. Thank you for that. We're just going to go quickly over a summary. We're going to take a quiz together, and then we're going to have lunch. Okay. Requirements for requalifying DOT cylinders, right? You want to pull out that chart. First steps, requalification date, numbers, everything where it should be. Have your visual inspection reports ready. Make sure that people fill those inspection reports out in a way that's legible also. Whether you have this electronically on a tablet or not, that I don't know. That's not a bad idea. But I would also keep a paper copy just because things happen with tablets and computers and things of that sort. Prepare the cylinder for inspection by emptying the cylinder, removing any rust, cake, paint, dirt from the cylinder, and marking any potential problem areas. This is it. Prepare it, inspect it, leak test it, and what is the process? Are you going to condemn it? Are you going to reject it? Or are you going to say, we're good to go? You can fill it. And this is the entire decision tree process. If you can understand this, and you can understand the criteria based upon some of the charts and tables that we looked at, then you're good to go. Just have to make sure that you're consistent. Consistency is really, really important. Disposition of cylinders after inspection on your form. It's either going to be okay, it's going to be R or RM or SC. You know, mark cylinders that have been out of date and need to be marked again that pass inspection. It's going to be an okay with the RIN and a requalification date followed by the letter E, right? Because it's just been the inspection and you're good to go, and now you're putting the new inspection date on it. Cylinders that are rejected during the inspection must be marked RM with paint or waterproof markers. Same thing with a cylinder that is scrapped. However, Cylinders that are condemned or scrapped must be stamped with XXX over the DOT specification number and pressure stamp, or stamped with condemned on the neck ring, top head, shoulder, or rendered incapable of holding pressure. How do you render incapable of holding pressure? Take the valves off if you don't have a stamp. Special requirements, we talked a little bit about that. Talked about aluminum cylinders, composite stationary cylinders, motor fuel and forklift cylinders are not interchangeable with each other. Now let's see here. What would you do? You see these, right? Just for thought, you know, you look at these, you're like, well, that's just some surface, but you don't know. And that's why you have to use your pit gauge and your straight edge to measure and use the table. How about this one? This one looks pretty bad. I don't know that, looks like I got a couple of bullet holes in there. This one I might just go ahead and scrap. Call me crazy. But this one was online at an auction. And here's where it gets a little bit dangerous, guys. I can't really tell, even though it looks like a lot of surface because maybe it's old. I can't tell whether or not this is good to go or not. I can guarantee you that whoever bought it, or I can almost guarantee whoever bought it, did not do the proper visual inspection that you all are going to do. But some of these things find themselves in the field. Now, the good news for those that are going to requalify cylinders is plenty of work for you guys. I mean, there are just a gazillion cylinders out there, and they all need to be at least inspected. So we're going to go to the course quiz now. It's important, I think, that we have the answers to this. Again, if we had more time, I would query the class and do this together, but for expedience purposes, we're going to go this route. In the event of a propane emergency, you should always place personnel and customer safety first. Friends, I can't overemphasize that. Sometimes things happen and we get so focused on fixing them. There might be an uncontrollable leak somewhere, whether it's a cylinder or a large tank, and we get fixated on fixing that leak because we're can-do people. But no, as we're fixated on fixing that leak, we end up having perhaps an ignition and an explosion. And that's what happened. For those of you that know about Gent, West Virginia, that happened years ago. It's an uncontrollable leak, make a long story short, of a propane tank. This is during a tank-to-tank transfer. It's hooked up to a little general store. They had propane-powered pizza ovens. It was an uncontrollable leak during the tank-to-tank transfer. It was a junior technician, instead of him immediately evacuating everyone, getting himself safe and call 911, he spent about 10 or 15 minutes trying to control the leak. The building blew up and people died. So whenever I talk about safety and I talk about training, sometimes it's not only that you didn't get the training, but that we're in the moment. Something happened. We have to fix it. No, we have to get personnel and customers safe before we can do anything. My soapbox talk. Which of the following are not approved testing methods for DOT requalification? External hydrostatic compression test. There's no such thing as that. There's an external visual test and there's a water jacket hydrostatic test. Personnel responsible for the requalification of DOT cylinders by external visual inspection must be thoroughly familiar with what? Everything except for EPA, but mostly CGA. ASME is more tanks. CGA standards are subsumed within this text. So we are good to go. Number 4, in which case is it not acceptable to use ditto marks on a cylinder requalification inspection form to indicate repeated information for the preceding entry? And that would be C, cylinder disposition, because that could change from cylinder to cylinder, right? Person handling the cylinder, the dates, they're going to be pretty much the same. And who wants to write their name over and over again? 5, to prepare for a DOT cylinder requalification inspection, just preparing for it. You need to perform all of the tasks below except A. We don't need to add 5% liquid to the cylinder. We need to do those 3 things beyond inspection forms, cylinder date requirements, and preparing it for inspection, such as cleaning the inspector. If the last requalification date on a cylinder is 03, that's March 15th E, external visual, when is the next requalification due? Well, it's 5 years, due March 2020. Okay, we look at the date that's on there. We look at the letter. If it's an E, it's within 5 years. Match each picture with the type of damage that it shows. Let's go to our book on page 109. If we look at the picture on A, well, that looks like some valve damage there. And it also looks like some green corrosion, which is often a sign of illicit use of making methamphetamine. Now, if you can get the cylinder from somebody that has this, go ahead. If not, mark that and consider calling the authorities about that one. Follow your company policy on that one. B, the cylinder in B, looks like a lot of fire damage to me. On C, we're looking at corrosion. On D, we've got some dents, if you could see on the top left side of the cylinder. On E, we've also got some damaged attachments there. The neck ring looks pretty well damaged. And on F, it's a little hard to say. It's maybe a little bit of corrosion there. Quite frankly, it doesn't look so bad to me on that picture, but there could be a little corrosion on there, maybe some line corrosion, some gouges that you may want to look at. And on G, again, looks like fire damage. You see that black top, and sometimes it gets kind of discolored or a bit shiny as well. 8, which of the following is not specifically included in the requalification inspection of a DOT cylinder? Nowhere did we talk about scuffs. Cuts, gouges, dents. No scuffs. Number 9, the leak test step in the requalification process should be performed using propane vapor. Vapor, not liquid. Liquid expands 270 times when it escapes, so we don't want to use liquid to test for leaks. Number 10, CGA-C6 stipulates that if the weight loss is between 90 and 95%, this is when we're talking about corrosion, pits, digs, gouges, the cylinder can be requalified by the water jacket or direct expansion testing. That's true. That's true. It can only be requalified using that method, but as we talked about, sometimes the cost of doing so is not worth reclaiming the cylinder. Number 11, a successfully requalified cylinder should be marked as such on the collar. A customer brings in a cylinder that he or she owns for requalification and filling. No, this gets to what you were saying. The result of the inspection is it's being condemned. SC. What do you do next? Verbally notify the cylinder owner that the cylinder is condemned and cannot be filled. The hazardous material and offer for transportation and commerce. What you do beyond that, and of course you want to document all of that, you don't own the cylinder. And as we mentioned, you could say goodbye to the customer, offer them a new cylinder at cost, or provide them with a new cylinder at your cost. You cannot take it away. You don't own it. Number 13, aluminum cylinders that have been exposed to fire must be immediately removed from service, condemned, or scrapped. Full stop. End of story. Number 14, DOT cylinder and stationary service should be requalified 10 or 12 years from the date of manufacture and every 5 years thereafter, with the exception of the requirement of tear weight verification. We're going to look at everything else, leak test, look at the attachments, don't have to do the tear weight verification. Why? It's speculated that they just don't get knocked around a lot. They're not going to see a lot of that damage to them as you would otherwise. 15, engine fuel cylinders used on industrial, such as forklift trucks, are not required to be equipped with what? An overfill prevention device. no OPD. Number 16, isolated pitting, where line corrosion could be missed on visual inspection if you don't. A, remove all dirt, paint, and other rust from the cylinder before inspection. Sure, if you've got some dents in it, you can't find that. A lot of things you won't see if it's not cleaned off. You are inspecting a 100-pound 4B240 cylinder. You know that because it says it on the collar. Or it's on the top of the cylinder. That has an area of line corrosion measuring 5 inches long, the depth of 0.034 inches. Using the LP gas cylinder damage limits chart, can that cylinder be requalified? And the answer is yes. If you look at the chart and you look at something that is measuring 5 inches long, the maximum is 0.035 limit. You've got 0.034 limit, so we're good to go. Again, looking at the nomenclature, knowing what we're looking at, knowing it's a 4B240, 100 pounds, knowing how to use our charts and tables, we'll make the right decisions all the time. 18, and if you want to know, there's 24 questions to the quiz. You are inspecting a cylinder that has a dent on a weld. Dent on a weld. The dent has a depth of 0.29 inches. What should you do? Reject the cylinder. Maximum a quarter inch deep on a weld has to be rejected. 0.25 inches is greater than a quarter inch, which is 0.25 inches, so it has to be removed. Any dent on a weld greater than a quarter inch deep or 0.25 inches, you have to say goodbye to. 19, you determine the minimum allowable tear weight for a specific cylinder to be requalified. Multiply the marked tear weight by 0.95, no more than a 5% loss. Right? If it's less than that, it has to be requalified or condemned. 20, there must be at least 5 continuous full threads for tapered cylinder neck threads to pass qualification inspection. We saw that picture of the threads and how they were damaged. There has to be 5 of them, not 4, but 5. 21, if a leak is found at a threaded opening, you may reseal it and test it again for leaks. Very important, leaks on a threaded opening. 22, we're getting there. If the cylinder is rejected during a requalification inspection and marked RM on the report, you should mark the area of the cylinder that failed inspection with paint or waterproof marker, like a Sharpie or something. By the way, if you have any of you have grandchildren or small children, do not have Sharpies. Do not have Sharpies in your home, especially those that do not come out. I've learned that through my years of parenthood and grandparenthood. When a cylinder in stationary service is inspected and requalified at the customer site, you must include the RIN in the requalification stamp. Not true. Only when doing it in the field. Just like we talked about stationary, right? When a cylinder in stationary service is inspected and requalified at a customer site, you don't have to include the requalification stamp. Only for stationary service at a customer site. Small engine cylinders are very similar to forklift cylinders, except that they typically have left-handed threads and threads on male and female safety couplers. That is why they are not interchangeable. Friends, as you look from page 115 onward, there's a lot of great reference material there. There's a copy of a visual inspection method application. I want to just end off the way I started, a little bit being on my soapbox, if I may. I've dealt with a lot of people that look down their nose at me and look down at their nose of people that wanted to help keep them safe. It's a testament, folks, like Billy's bringing his people on, and he's taking the class himself. I think that's fantastic. I love when people do that. Many times you hear from managers, bean counters, say incidents and accidents are down. Guess we don't need to invest in safety anymore, they say with a chuckle. Well, there's a notice that says no hiding in the restroom during safety meetings. I like to have a good laugh too. I think that pretty much undermines what we do in the safety field. You don't have to be a safety professional to be a professional. There's only one way of doing things. You do it professionally. Professionals do things safely. I'm fine for a good joke too, but it undermines us. I want to leave you by saying, I like a good laugh, but it's not fun until someone gets hurt. Friends, I have never had to go to a spouse's home and tell them that their loved one is not coming home because of an industrial accident, because maybe they did something they shouldn't have done or they listened to a fool. I've never had to do that. I know some folks that have done it, and there might be some of on this class that have done it. And to a person, it's a life-changing experience. They never forget it. They never get over it, especially if they're a supervisor, whether, I'm not saying it's their fault. So I want to leave you with this. This is my daughter, my 2 grandchildren I'm blessed to have. It's kind of the reasons that I try to work safe on the job and off the job. The reason you want your customers to be safe. It's the reason you want to be safe. It's the reason you don't want to take shortcuts. This is what it's all about. Friends, I want to thank you for your time. My email address is sflatow@aol.com, which somebody told me recently means aging online, which is okay. Please, any questions or comments, I would appreciate, I think I have all of your email addresses and your names. If you would send them to me at your convenience to make sure that I have it and your company, I will dispatch the appropriate certificates of completion, either yourselves or your supervisor. And with that, any other questions? I think that I think I've unmuted all of the phones. And so if anybody has something they want to say.
Good job.
Oh, thank you.
Appreciate it, Stuart. It was very informative.
Well, thanks. Thank you. I know we went quickly, but the idea at the end of the day is to know how to use this book and know who to call. I want to thank you all for your time and remind you again to please send me your brief information. Yeah, friends, thank you all so much. I really appreciate it. Have a wonderful and safe Thanksgiving. Watch out for those turkey fryers. Bye, everybody.